we're going to see merge sort. So merge sort is a sorting technique where I split element by level, element by element, and then go on merging it those element by element. See here, so as I merge them, I'm sorting it. Like for example, here 38 and 27, I split that into 38 and 27 like this, and then I sort it. Here also I split it to every element level, and then I sort the result. So here I'm getting 10 and 43. Then here I have 27, 38, 10, 43. So here I'm doing, when I'm merging it all, I'm getting 10, 27, 38, 43. This is the final result that I get. I recursively split the array, and when I'm merging those, I sort. So one thing to note here is there will be a pointer to the left array, there will be a pointer to the right array, and when we are merging, let's say if the element on the left is smaller, I take that and then I increment the pointer for the left. If I take the element on the right, I increment the pointer for the right. So the algorithm basically begins with calculating the middle element and splitting the array at that middle element, and then calling the merge function. Under the merge function, let's say if I have two arrays of 3 elements each, and I will compare the first element and the first element. I will add it to the final list and increment the pointer for whichever list the element, from whichever list the element was added. In any of the case, I have to increment the pointer for the list to which I'm adding the items. If I reach the end of any of the list, I stop this while loop and copy the remaining elements of the other list as it is. These are the main key points of the algorithm. Let us take, we have this 38, 27, 43, 3, 9, 82 and 10 get split like this. 38, 27, 43, 27, 43 gets further split like this. So basically the idea of splitting is, when I call the merge function, it merges it in sorted order. So here also I am splitting level by level. Now when I have to sort, I'm 2743 was at one level, so I sorted it. Then here these three were at one level, 27, 38, 43. Now I have the left side of the list ready. Similarly, 3 and 9 are put as it is, 82 and 10 as 10 and 82. Now I have two sorted sublists, 3, 9, 10 and 82. I take 3, I compare 3 with 10, then I compare 9 with 10, and one end of the list is reached, so it will just add 10 and 82 to the final list. Now I have these two sorted lists. So first of all, it will compare 3 and 27. 3 will be taken in. Then it will compare 9 and 27. 9 will be taken in. 10 and 27. 10 will be taken in. It will compare 27 and 82. 27 will be taken in. 38 will be taken in. 43 will be taken in. And then finally, because end of one list is reached, it will just add the remaining elements here to the list. So 82, and if there is any element forward, it will be added to the list as it is. The complexity here is O of n log n. Let me also show you. Let me also show you the program for this. So merge sort, the length of the array. Here I'm calling, I split the list into left and the right, and then I call merge sort on the left part of the list and the right part of the list. I initialize ijk is equal to 0. if I is less than and if I is less than length of left, that means if the end of the list is not reached for the first list, and if the end of the list is not reached for the second list, then in that case I check left of I less than right of j, and here I will add left of I to the final list and increment the pointer for the left. Here I will increment the pointer to the right, and this is the pointer for the main list. Here this is to copy the remaining elements that are there. Same portion of code as what we had here, but just that it is being split.